find the partial derivative with respect to x and the partial derivative with respect to y. For the partial derivative with respect to x, which is a partial derivative with respect to x of the function natural log of x to the third plus 4xy. This is a composite function. We have the natural log as an outer function and x to the third plus 4xy as the inner function. We're gonna do one layer at a time. Starting with the log first. Then we have 1 over the quantity x to the third plus 4xy, and then multiply by the partial derivative with respect to x of the quantity x to the third plus 4xy. When you find the partial derivative with respect to x, we target the x variable. So we treat y and other as a constant term. Then for this portion, the derivative with respect to x is going to be 3x to the second plus 4 times y, because we treat 4 and y as a constant multiple. Then the partial derivative with respect to x is the quantity 3x squared plus 4 times y, all divided by x to the third plus 4xy. And you can write in the shorter notation that f subscript x. Next, we are going to find the partial derivative with respect to y of the given function natural log of x to the third plus 4xy. When you find the partial derivative with respect to y will be treated as a variable and the rest gonna be the constant. I'm gonna use different one. So this is the x to the third, 4, and x will be treated as a constant term. We apply the chain rule. Log as the outer function, it's going to be 1 over the quantity behind the log, x to the third plus 4 times x times y, and then multiply by the partial derivative with respect to y of the quantity x to the third plus 4 times x times y. Since x and 4 are constant, so the derivative of x to the third with respect to y going to be 0. And then 4 times x here as a constant, multiply to y, the derivative with respect to y gonna be 4 times x times 1. Now, we wrap it up. The partial derivative with respect to y of the function f is 4x, which is the numerator, divided by x to the third plus 4 times xy, or the f subscript y as a shorter notation of the partial derivative of the f with respect to y.